Key methods of performance metrics.
The key performance metrics methods are confusion matrix, accuracy, precision, recall, specificity, and F1 score. Let's proceed to learn more about each of them. Confusion matrix. The confusion matrix is one of the most intuitive and easiest metrics used to find correctness and accuracy of machine learning models. It is used in classification problems where the output can be of two or more types of classes. The confusion matrix is, in itself, not really a performance measure as such, but almost all of the performance metrics are based on the confusion matrix and the numbers inside of it. To further understand what the confusion matrix is all about, take a look at a case study of a cancer prediction system. Let's say we're solving a classification problem where we're predicting whether a person has cancer or not. The management of a cancer research center wants a cancer prediction system. They approach a company and explain their requirements. The consultant explains the different approaches that can help predict cancer in people to the CEO of the Cancer Research Center. So, how do we do this? Let's give a label or class to our target variable. 1, when a person is having cancer, and 0, when a person is not having cancer. Now we have identified the problem. The confusion matrix is a two-dimensional table with actual and predicted sections. The set of classes are given in both dimensions. Actual classifications are added to columns and predicted ones are added to rows. Let us look at different terminologies involved in confusion matrix. True positives are cases when the actual class of the data point was 1, true, and the predicted is also 1, true. For example, the case where a person actually has cancer and the model classified this case as cancer comes under true positive. True negatives are cases when the actual class of the data point was 0, false, and the predicted value is also 0, false. For example, when a person does not have cancer and the model classifies the case as not cancer, it comes under true negatives. False positives are when the actual class of the data point was 0, false, and the predicted was 1, true. It is false because the model has predicted incorrectly, and positive because the class predicted was a positive one. For example, a person does not have cancer and the model classifies the case as cancer. False negatives, finally, are cases when the actual class of the data point was 1, true, and the predicted value was 0, false. It is false because the model has predicted incorrectly, and negative because the class predicted was a -1. For example, a case where a person has cancer and the model classifies it as no cancer, it is a false negative. The ideal scenario is 0 false positives and 0 false negatives. But that's not the case in real life, as no model will be 100% accurate all the time. So now, the CEO has understood the concept of actual and predicted classification. But he still wonders when and what should be minimized. There will be some percentage of error associated to any model that we use for predicting the true classes of the target variable. These will result in false positives and false negatives. That is the model classifying correctly as compared to the actual class. There is no hard rule that determines what should be minimized in all situations. It depends mainly on the business requirement and the context of the problem to be solved. Based on that, we might want to minimize either false positives or false negatives. let's consider an example for minimizing false negatives. Let's say, in the cancer detection scenario, only 5 out of 100 people have cancer. Here, a very bad model predicting everyone as non-cancerous will give us 95% accuracy. However, to capture all cancer cases, we might end up making a classification when a person who does not have cancer is classified as cancerous. This might even be considered okay as it is less dangerous. However, missing a cancer patient will be a huge mistake as no further examination may be done for them. Now, let's take an example of minimizing false positives. To better understand false positives, let's use a different example where the model classifies whether an email is spam. Let's say that you are expecting an important email, like hearing back from a recruiter or awaiting an admit letter from a university. Let's assign a label or class to the target variable and say 1, email is spam, and 0, email is not spam. Suppose the model classifies that email that you're waiting for as spam. It is a case of false positive. Now, this situation is worse than classifying a spam email as important or not spam, in which case you can still go ahead and manually delete it. It is not a pain if it happens once in a while. So, in the case of spam email classification, minimizing false positives is more important than false negatives.